Of the students who choose to live on the East Coast College campus, 10% are seniors. Okay. The most desirable dorm is the newly constructed Ocean View dorm, and 60% of the seniors who live on campus live there, while 20% of the rest of the on campus students live there. So I gotta be honest, this has been a bit of a perplexing problem for me. I've tried a Venn diagram and I was really not able to fill in all the missing pieces. And I've kind of decided that what I'm going to try is a two-way table. And as I look at it, there's two categories, right? You're either a senior or not a senior. So one of the things is, senior, not senior. The other thing is Ocean View. You either live in Ocean View or you don't live in the Ocean View dorm. The problem that I have is that when they talk about this, we've got 10% are seniors that live on campus. That means 90% of the students on campus are not seniors. And then there's this other thing that 60% of the seniors who live on campus live in Ocean View. So, and then while 20% of the rest of the on-campus students while 20% of the rest of the on-campus student residents live there. Okay, so 20% live in Ocean View. So let's take a look at this. So I think this is the setup I want for my two-way table. And I guess, one of the things that I know is that, and we normally don't write these margins down, but I'm going to put it here because at least it's something I know. I'd have to talk about 100% of everyone by the time I get to this particular box. And as far as being a senior and living in Ocean View, I know that it's not 60% of the seniors who live on campus live there because it can't be 60% because that's not it's not 60% of the campus, it's 6% of 10%. So what I've decided is that this upper box here, Ocean View and seniors, is it's 60% of the 10% who live on campus. So this should be 0.6 times 0.1. And when I do that multiplication, I get the very small 0.06. So again, this 100% represents the entire campus. And of the entire campus, 6% of that is the seniors who live on campus and live on Ocean View. Now, if 6% of the seniors live on Ocean View and they're only 10% of the overall campus, that means this the people who live on campus, that means this has to be 4%, not 40%, 0.04. So 0.04. So when I add those two together, it is nice that I do get the 10% right there. So if you look at it, seniors, 10% of them live on 10% of the people on campus are seniors. Now that means that 90% of the people are not seniors. So again, this is seniors on campus, and the people on campus, 10% are seniors and 90% are not. This is still confusing. I might record this again because I'm still trying to get a grasp on this. Let's see what else I know here. I also know that, let's see, if it says while 20% of the rest of the on-campus students live there. Okay, so if 10% are seniors, that means 90% is the rest of the students that are living in the dorms. And of that 90%, 20% live in Ocean View. So I think if I've got this right, 20% of the 90% of the people who live on campus live in the Ocean View dorms, and that's only 18%, right? It's 0.18. Well, if that's 18%, and this needs to add up to 90%, not seniors, 90% minus 18% would be 72%. So that means that 72% of the people that live on campus are not seniors, and they live in a building or buildings other than Ocean View. And I guess I could fill in the other marginal stats here. So let's see. That would mean in total that people that don't live in Ocean View would be 76% of the entire student population that live on campus. I guess I have to keep reminding myself, this is of the people that live on campus. And then that would also mean that 24% of the people that live on campus live in the newly constructed Ocean View dorms. So Ocean View looks like it's it's almost a quarter of all dorm rooms on campus, or it's capable of holding almost a quarter of all the students who choose to live on campus. So as you can imagine, this was difficult with a two-way table. I think it's impossible. I found it impossible to try and represent all this using a Venn diagram. And it might be worth it to watch this and think about it a couple more times. But I think now we're nicely set up to answer question B. It says, what is the probability that a randomly selected resident of the Ocean View dorm is a senior? That does feel relatively simple. So let me look at this again here. What is the probability that a randomly selected resident of the Ocean View dorm is a senior? So we're talking about only this 24% of the campus. So what is the probability that a randomly selected student that lives in Ocean View, so that's Ocean View, yes, is a senior? And that would be senior, yes. So I'm looking at this. I'm looking at, and I guess I'll write these as percent. So it looks like it's 6% out of the 24%. So if I express that as a percent, and what 6 times 4 is 24, so this does reduce to 1/4. So I would say that probability is 25%. So what is the probability that a randomly selected resident of Ocean View? Okay. Now Ocean View, it does have, most of the seniors that live on campus live there, but it's a pretty big facility, and only 18% of the non-seniors that live on campus live there. But the probability that I pick someone from that building that is a senior is high. It's 25%. And if I look at it, what's the probability that a senior lives in one of the other places? That's significantly smaller. It's not a question here, but notice that would be just 4% of this. So I could do 4 out of 76, and that looks like, yeah, that's about only 5%. So if you're a senior, what's the probability that if you randomly select a student that lives on campus that is not living in Ocean View, it's only about 5%, 5.2%. So it's a significantly lower probability that they would be a senior in that situation than the 25% probability that if you select someone who's living in Ocean View that they're a senior. Anyways, I think we just need to take this slowly and kind of breathe. And I'm sorry that I've spent almost 10 minutes talking about this problem, but it's what I needed to do. So if you find it helpful, great. If not, please don't watch this.